Welcome to the Deep Dive. We're here to give you that ultimate shortcut to being well-informed.
Mm-hmm.
And today, we are really diving deep into the architecture of, well, the human mind. How we think, how we categorize things, solve tricky problems.
And maybe why our brains sometimes take these, mental shortcuts that can lead us astray.
Exactly.
So our mission today is to help you get a clearer picture of your own cognitive software, so to speak.
Right.
It's not just about definitions. It's about seeing the patterns, the systems in how your mind works, where they might fail.
And how you can maybe consciously tweak things for better performance.
Precisely how you can upgrade your mental toolkit.
Speaking of performance, let's kick off with a really powerful example of human ingenuity. The incredibly fast development of the COVID-19 vaccine.
Oh yeah, truly remarkable.
When the world hit this huge, seemingly impossible problem, scientists just leveraged decades of research to, well, essentially teach our immune systems how to fight this new virus using RNA. So it's just stunning stuff.
It absolutely is. And our sources point out something amazing about the speed the Moderna vaccine. Its core design was basically worked out within days of the virus's DNA sequence going public.
Days.
Wow. That's not just luck. That's, the result of intense cognitive effort, years of preparation, meeting the moment.
But it's never just a science in a vacuum, is it? When we looked into it, there's this amazing human detail.
Ah, the Dolly Parton connection?
Yes. The Moderna trials got a huge boost from a $1 million donation from Dolly Parton.
It's fantastic.
It really highlights that solving big human problems takes more than just raw intelligence. It needs resources, support, sometimes even unexpected generosity to make things happen.
And that kind of all-hands-on-deck effort really brings us to our main topic, cognition.
Right.
Which is, the whole range of mental stuff involved in remembering, thinking, knowing. It's the engine driving everything upstairs.
Okay, let's unpack that engine. Because to even start studying it properly, psychology needed a revolution almost.
That's right. For a long time, the main view was behaviorism. Think B.F. Skinner. They basically said psychology should only look at observable actions.
The mind itself was like this black box. Too messy, too abstract to study scientifically.
Exactly. Best just ignore it. But then the 1950s happened, and along came the modern computer, thanks to people like John von Neumann.
And this is where it gets really cool. Because the computer wasn't just a tool, it became an analogy.
The perfect analogy. Suddenly, psychologists could think, okay, the brain is the hardware.
In cognition, those mental processes, that's the software.
And this whole input process store output model, like how a computer works, gave them a framework. Sensory info comes in.
Gets processed, stored.
And then a behavior or response comes out. That shift, that analogy, that's what launched the cognitive revolution.
And right out of that came artificial intelligence, AI. Building machines that can do things which, require intelligence when we do them.
AI is incredibly potent because it beats humans in certain areas, right? Speed, relentless persistence, massive memory capacity.
Like during the pandemic again.
Exactly. AI was crucial for things like projecting virus spread, sifting through mountains of medical images way faster than any human could, improving diagnostics.
Okay, but the minute AI starts interacting with human systems, we hit this issue of objectivity. Or maybe the lack of it.
A huge issue. Because AI is only as smart or as fair as the data it learns from.
We saw this play out even in the art world. Remember that AI-generated painting, Edmund Bellamy, sold for over $400,000.
Yeah, showed creative potential, but that potential is totally dependent on its training data set. What did it eat to learn?
And if that data it eats is full of historical biases, say systemic racism or sexism,
then the AI learns those biases, it internalizes them, and spits them back out. This is so important for you, the learner, to grasp. If an AI is trained on biased data for things like loan applications or predicting recidivism in criminal justice,
it's going to make biased decisions. It perpetuates the existing inequalities baked into the data.
Even if you try to clean the data, remove obvious things like race, if other factors correlate like zip codes or income proxies, the bias creeps back in. It's a high-tech version of garbage in, garbage out.
So we absolutely have to question the assumptions built into these powerful tools, not just marvel at their speed.
And it ties right back to how we think. Because thinking is fundamentally about manipulating information mentally, forming concepts, solving problems, making decisions.
Let's start with the building blocks.
Yeah.
Concepts. These are just the mental boxes we use to group similar things, dog, furniture, game.
And concepts are vital. Our sources list 4 key reasons. 1, They let us generalize. No chair, you can use any chair.
Okay.
2, they help us associate experiences. Baseball, soccer, both examples of the concept sport. 3, they make memory-efficient chunking information.
Got it. And 4.
They give us clues on how to react. If you know that weird-looking dish is food, you're less hesitant to try it, right?
Makes sense. So how do we decide if something new fits into a concept?
Usually we use what psychologists call the prototype model. We don't check a list of features. We compare the new thing to our mental best example or ideal member of that category.
Ah, so like a robin just feels more like a bird than a penguin does, even though both are birds.
Exactly. The robin is closer to most people's prototype of a bird.
Okay, so we have concepts. Now, problem solving. It seems messy, but there's actually a structure to it, right? Like 4 steps.
Generally, yes. Step 1. Find and frame the problem. This is often the hardest part, seeing an issue others just accept.
Then step 2, develop strategies. This is where you break it down into sub-goals, or maybe you work backward from where you want to end up.
Right. Step 3 is evaluate your potential solutions. And step 4 is crucial. Rethink and redefine. Keep revisiting the problem. Maybe the initial framing was wrong.
When we're developing those strategies, we seem to have 2 main ways of thinking.
We do. There are algorithms. These are like recipes or formulas. Specific steps, guaranteed to get you the right answer eventually, but they can be slow and cumbersome.
Like following IKEA instructions perfectly.
Ha, exactly. Takes forever, but it should work. Then there are heuristics. These are the mental shortcuts, the rules of thumb.
Faster, right? But not guaranteed.
Much faster, more intuitive. They suggest a solution, but they don't promise the best one, or even a correct one. We use them constantly because algorithms just take too much mental energy for everyday life.
But relying on those shortcuts leads to problems, like getting stuck.
Yes, fixation. That's when you keep trying the same old strategy even when it's not working, failing to see the problem from a new angle.
And a common type is functional fixedness.
The classic example. Being fixated on an object's usual function. You need a hammer, but all you have is a shoe. Functional fixedness stops you from seeing the shoe as a potential hammer.
Or that famous string problem. 2 strings hanging from the ceiling, too far apart to grab both.
Right. The Mayer string problem. You've got pliers nearby. Most people get stuck seeing pliers only as a gripping tool.
But the solution is to tie the pliers to one string.
And use them as a weight to make a pendulum. You swing it, and then you can grab both strings. It requires overcoming that functional fixedness, seeing the pliers' potential beyond their usual function.
Like forcing your brain out of its rut, shifting gears.
Exactly. It often involves moving between System 2 thinking slow, analytical, effortful, and System 1 fast, intuitive, heuristic-driven. But System 1, while quick, is where the biases tend to lurk.
Okay, let's talk about those decision-making biases.
Yeah.
System 1 failures. One big one seems to drive a lot of our choices. Loss aversion.
Oh, absolutely. Loss aversion is this powerful tendency where the pain of losing something feels much worse than the pleasure of gaining something equivalent.
How much worse?
Some research suggests losses feel about twice as impactful psychologically as gains do.
Wow. So if you're thinking about, say, asking for a raise, your brain isn't weighing the potential gain versus the risk of awkwardness equally.
Not at all. It's heavily magnifying the potential loss, the embarrassment, the rejection compared to the potential gain of more money.
And that feeds into the sunk cost fallacy, doesn't it?
Directly. That's when you refuse to give up on something, a project, a major, or even a bad relationship, because you've already invested so much time, effort, or money into it.
Even though rationally, that past investment is gone no matter what you do now.
Right. But loss aversion makes abandoning it feel like you're confirming the loss of all that past effort, so you stick with it, even if it's the wrong path going forward.
Another tricky one involves stereotypes and statistics. The representativeness heuristic.
This is when we judge how likely something is based on how well it matches our mental prototype or stereotype, rather than looking at the actual statistics, the base rate.
So that classic example, you have a group, say, 95 engineers and 5 librarians. Someone walks in who's quiet, wears glasses, seems bookish.
Your System 1 screams librarian because they fit the stereotype perfectly.
But the base rate, the actual statistics, makes it overwhelmingly more likely they're an engineer.
Right.
95 to 5 odds.
Exactly. But we consistently ignore the base rate information in favor of the vivid, representative individual description. System 1 jumps to the conclusion that feels right, even if it's statistically wrong.
Our minds just default to these quick, often flawed judgment.
Which brings us to maybe the trickiest concept in all of cognitive psychology, trying to define and measure the overall quality of these complex, sometimes biased minds, the whole idea of intelligence.
And right away, you see it's hugely influenced by culture, isn't it?
Absolutely. What counts as smart varies enormously. In the US, we tend to emphasize analytical reasoning.
But elsewhere.
While in parts of Kenya, intelligence might be seen more in terms of responsible social participation, knowing your role in the community. Or among the Atmul people in Papua New Guinea, it involves memorizing tens of thousands of clan names. The definition depends on what the culture values and needs.
Now, before we dive into how intelligence is measured, particularly in the West, we have to touch on some really difficult history.
We absolutely do. Early figures in intelligence research, like Charles Spearman, who proposed GLA or general intelligence, were also proponents of eugenics.
That awful idea of improving the human species through selective breeding.
Yes. And it's a chilling fact that early IQ tests in the US were actually used quite horribly before WWII as a basis for forced sterilization programs.
It's crucial context. It shows how easily a concept like IQ can be misused with devastating consequences.
It really underscores the need for caution and ethical considerations when we try to measure something as complex as intelligence.
So, with that history in mind, how do we try to measure it responsibly today? What makes a good test?
Well, any good psychological test needs three things. First, validity. Does it actually measure what it claims to measure?
Like, does an IQ test score actually predict, say, school grades? That would be criterion validity.
Exactly. Second, reliability. Is the test consistent? If you take it again, will you get a similar score?
Okay. Validity, reliability. What's the third?
Standardization. This means everyone takes the test under the same conditions, and importantly, we establish norms. We figure out what average scores look like, what's high, what's low, for different groups.
The whole concept really started with Alfred Binet in France, trying to identify kids who needed extra help in school. He came up with mental age.
Right, comparing a child's score to the average score of children at different ages. The old IQ formula was mental age divided by chronological age times 100.
We don't really use that simple formula now, do we?
Not really. Today, the Wechsler scales, WAIS for adults, WISC for kids, are much more common. They give you scores on different aspects of cognition, not just one single number.
Now, a really controversial area is heritability. Research often estimates intelligence heritability around 50%. What does that even mean?
That's a great question because it's so easily misunderstood. First, heritability is a statistic about variation within a group, a population. It says nothing about where your specific intelligence comes from.
So it doesn't mean 50% of my IQ comes from my parents' genes.
No, absolutely not. It's about what explains the differences in IQ scores across a large group of people. And second, it does not mean intelligence is fixed or predetermined by genes.
Okay, that's crucial.
Genes and environment are always interacting. Heritability itself can change depending on the group studied and their environment. If everyone had the exact same environment, heritability would look higher. If environments vary wildly, it looks lower.
And the evidence for the environment's impact is just massive.
Overwhelming. Look at the Flynn effect. IQ scores have been steadily rising across the globe for decades.
Too fast for genetics to be the cause.
Exactly. It has to be environmental factors, maybe better nutrition, more complex schooling, more exposure to abstract problem solving.
And we know specific interventions work too.
Definitely. Things like high-quality preschool for disadvantaged kids can raise IQ scores by a significant margin, maybe 4 to 7 points. Even simple things like dietary supplements, iodine, omega-3s, or just reading interactively with young children show positive effects.
So intelligence is definitely not set in stone. It's something we can cultivate.
Which fuels that ongoing debate. Is there one single G factor, like Spearman thought, or are there multiple intelligences, like Sternberg's idea of analytical, creative, and practical intelligence?
Or Gardner's theory, with like 9 different types: musical, spatial, interpersonal.
Right. Regardless of how many types there are, the key takeaway is that our cognitive abilities aren't fixed. They respond to challenge and experience.
Which brings us nicely to a really practical application. Using these cognitive ideas to manage stress and boost well-being through something called cognitive appraisal.
Yes. When something stressful happens, your mind first makes a primary appraisal. You interpret the event. Is this harm that's already occurred? Is it a threat of future loss? Or is it a challenge?
And framing it as a challenge is better.
Much better.
Yeah.
Seeing something as a challenge, difficult, yes, but something you can tackle significantly lowers the body's stress response compared to seeing it purely as a threat.
Okay, so first you assess the event. What's next?
Secondary appraisal. This is where you evaluate your own resources. Do you believe you have what it takes emotionally, financially, mentally to cope with this event?
So if you feel you have the resources, it feels less stressful.
Precisely. Your belief in your coping ability matters hugely.
And we can actively change these appraisals.
Yes, through cognitive reappraisal. This is the conscious effort to regulate your emotions by deliberately reinterpreting the situation or your reaction to it.
It's not just positive thinking.
No, it's more active.
Yeah.
And brain imaging studies, fMRI scans, actually show that when people successfully reappraise a negative situation, activity decreases in the amygdala, the brain's fear center. You're physically calming your emotional response.
Wow. And a powerful technique for this is benefit finding.
A really potent form of reappraisal. It involves intentionally looking for the good, the growth, the positive lessons or changes that might have come out of a really negative life event, even something traumatic.
Focusing on the upside, even when it's hard.
Yes. And research links this ability, this practice of benefit finding, to genuinely better long-term physical health and psychological well-being.
So wrapping this all up, we've seen our minds are these incredibly complex systems, shaped by history, built with specific cognitive tools.
Capable of amazing feats like vaccine design, yet constantly tripped up by predictable shortcuts and biases like loss aversion or functional fixedness.
But the key seems to be understanding these processes. Knowing how the software works allows us to potentially debug it or at least be aware of the glitches.
Exactly. And we talked about how tackling complex new cognitive tasks, like learning a second language as an adult, is a great way to build that mental flexibility.
Right, because you have to consciously fight your ingrained habits from your first language, like forcing your brain to hear the difference between L and R if you're a native Japanese speaker learning English.
You're actively training your brain to notice things it learned to ignore. It's peak cognitive flexibility in action.
So here's the final thought, the challenge for you listening. If mastering a skill like a second language demands that kind of deliberate effort to override old cognitive habits, what if you applied that same willful effort, that same cognitive flexibility, to actively noticing and questioning the social heuristics, the stereotypes, the ingrained biases that shape your everyday judgments and decisions?
What deep-seated assumption about people or about the world are you going to consciously force yourself to unhear or re-examine this week?
It's a powerful question. Keep diving deep into how your own mind works.
Keep testing that cognitive software.
And we will see you on the next deep dive.